All right, now let me show you why the exact equation method works. Because so far what we had p dx plus q dy equals 0. There was our ODE. And we basically found that F, which is our vector field PQ, is the antiderivative of F. And we claim that this means that f of xy is constant. And that helps us find a solution. Now let me show you why this is true. So, suppose you start with your initial condition, let's say 0, and then y of 0, and you just follow your solution. So you start here, and you see where the solution takes you. Then what you get is a certain curve. Not the same C, but here C is in curve, until you get to kind of any point that you wish. Let's call this xy, and this is really your function solution y. Now, what we want to do, we want to start with our ODE and integrate the ODE over this curve. Start with p dx plus q dy equals 0, and take the line integral. This, if you know what that means. So, line integral of p dx plus q dy plus q dy equals line integral of 0, which is 0. Think like a definite integral. That's on the one hand. On the one hand, if you integrate the ODE, you get 0. On the other hand, let's use the fact that f is an antiderivative of little f. So on the other hand, using that, f is pq, which is the gradient of little f, what we get is the line integral of p dx plus q dy. Well, by definition of p dx plus q dy and f being that vector field, that is the same thing as the line integral of f over the curve. But now we know that f is actually a derivative. So it's the integral of the derivative of little f. And whoever says integral of derivative says fundamental theorem of calculus. So in fact, there's something called the fundamental theorem of line integrals that tells you the integral of the derivative, it's f at the endpoint minus f of the starting point. So think f of b minus f of a. So f of the end of the curve minus f of the start of the curve. But what is the end? The end is just xy, any point that you want. The start is the initial condition. So this equals to f of xy minus f of 0, y of 0. And essentially just one more line, because what we get, so this quantity f of xy minus f of 0, y 0, which is really a constant, let's call it c, equals to this line integral, which we know is 0, sort of like following back. So f of xy minus constant is 0, and lo and behold, we get that f of xy is actually constant. Well, how cool is that? But as I said, intuitively, once again, it's true because the ODE says the derivative of little f is 0, more or less, and therefore f is constant. So it shows you that y has to solve this, but also if you want to show that y actually solves the differential equation, you would have to use the chain rule, and you can see the rest of that in the notes. Thank you.